Hi, and welcome to the tutorial to solder the owlBoard as part of CST 231 Digital Systems Design 1. Actually, it's Digital Systems Design 1. So this is a PCB we're going to have to be soldering. And I'll reduce the light a little bit. So what we're going to do is review, first of all, the safety procedures. Remember that we're going to be working with flux, which has volatile organic compounds, solder, which may have lead in it, and we will be using a hot soldering iron. So exercise caution. The other thing is always wear safety glasses. We might be using flux in the form of this liquid flux here. And there is flux built into this. Flux is what's used to help clean the connections in the board so that the solder sticks better. First component we put on is this Spartan 6. The text goes in the opposite direction of our logo. So first step is to actually align the chip. So let's see how this is going to go. I'm going to align this on all four. Right, we're aligned. It looks like we're aligned. We're a little off. This takes time on the stage because if you get it wrong, it will not work. And these chips are expensive, even though Xilinx donates them to us. If we run out, we have to buy more. So I'm going to take a little solder. Remember, this solder is a no-clean solder. It has a flux built in. I'm going to use a little flux here because when working with surface mount components like this, it's really helpful to put flux. And what I'm going to do is tack it in at each corner. We're not going for pretty or accurate here. We just want it to be tacked in so it doesn't move. Okay, so we tacked in the corner. Now let's see if you can see this. Let's move it in a little. Right, let's move it in a little. Just want to be able to see this. Okay, so let's see. Zoom in. Okay. So let me see here. I'm going to start feeding solder. Actually, you know what? Let's apply some flux. Oh yeah, and if you have some sort of fan device, please turn it on so that you don't have to smell this. Let's start at one corner, slowly feeding flux, and the tip, if you notice, is flat. So keep it parallel with the board. Keep going down. Keep going down. So keep going down again and again. Okay, don't keep it on for too long because it will ruin the board. Let's see here. On this side it looks good except for one thing over here, which I fixed. One thing over there. Looks like we're clean. Next side. Remember, we tacked the corners a little. So apply a little flux and just keep dragging down. Do not press into the chip. Just gently drag it. Right? Looks good to me. Next side. Be generous with the flux. If you need more flux, don't be afraid to use more. You can see right here, I didn't do a very good job, so what are we going to do? Well, I'm going to put more flux down. You don't necessarily need to wick it out, right? You don't need to necessarily use a wick, but all we want to do is kind of push the soldering iron in gently. Not really trying to hit it, we're just trying to heat it up so that the solder flows. right? That's a good clean connection. They're shiny, there's no shorts, right? If there was a short, it would look like this. Something like that. And to fix that short, you can either apply flux like this, or you can actually use some solder wick. I usually try to avoid the solder wick. We have one more side left. One more side left. Okay, here we go. One more time. Keep going. Okay, looks like we did well. Most of it's soldered, except, okay, so a little blob here. What am I going to do? I'm not going to use a wick. I'm going to use a little bit more flux. A little bit more flux. There we go. We got rid of that. So after you're done soldering, all we need to do is kind of go down each side. Make sure, let's zoom in a little bit more, if we can. Oh, nope. Okay, we're going to keep going in. It's very helpful if you have one of these cameras. Okay, shiny joints, no bridges. Shiny joints, no bridges. That's what we're looking for. Shiny joint, no bridges. Shiny joint, no bridges. No bridges, no bridges. Good. Shiny joint, no bridges. Shiny joint, no bridges. Keep going, keep going, keep going. We're good. Okay, shiny joint, no bridges. Okay, we're good. We're golden. We are done soldering this. Well, the QFP package. This is a QFP package, which means that it's quad flat pack, so it's a 144 pin package in this case. I'll zoom out a bit. Okay. Now what are we going to do? What do I feel like doing? I feel like doing the resistors. You know, there's capacitors too. So there's 330 ohm resistors here, which I'm going to use. The 330 ohm resistors are the ones that are going to be in the R100 range, all the way to, on the back, where is it? There should be one on the back too, but I'll target the ones on the front first. I'll empty them out. Black side generally goes up. What we want to do is actually, we have R100, so I'm going to put a little solder on this side, 102, 103, 104, 105, right, let's solder that up. Now we're going to take each resistor, this is a 330 ohm going into slot 100, R100. Be careful to not put too much solder, such that the other pad gets soldered. I'm going to do this, we're good. Right, let's actually zoom in a bit. So when you're soldering, make sure that you leave room enough for the other side to get soldered. So R101. Black side generally goes up. The resistors are not polarized. So let's keep going here. Uh-oh. These are not very good tweezers. And you don't want to put the heat on for so much time, because components are sensitive to heat. You don't want to heat them up too much. So we put all the resistors on here. What else can we do? I'm going to do the diodes right now because I like blinky stuff. So these are the diodes. They come in this sort of package. So let's see here. Let's open the package. Okay. So same thing as before. If we take a look, D1 to D8, so we have 8 LEDs on this side. I'm going to solder this pad first. And I'm actually going to turn the fan back on even though it's a little loud because it smells. If you get solder on the other pad, you should use some wick and heat the pad up. So if you look at this LED, actually you can't really see. There's one side, actually you can see. There's one side with the stripe. The stripe goes to the right. That's the cathode side. I'll place this here, make sure it sits flat. LEDs are particularly susceptible to the heat because it's a plastic package. So be careful. Don't apply it too much heat. Make sure you put the LEDs in the right direction. The stripe to the right. Uh-oh. Okay, we're going to keep going here if the LEDs will cooperate. And I need more LEDs. Remember that when you're soldering on this side, keep enough room so that you can still fill in the solder on the other side. I tend to tack all my components in at once and then go back. And remember, this LED, this is an 0805 package LED. Its lens is plastic. Do not keep too much heat on it for very long. Okay, we got all our LEDs in on one side. Now what I'm going to do is go back on the other side. Uh-oh. Okay. There we go. So D8. You don't need much solder. If you're blobbing up, it means that you're using too much solder. So notice I'm also touching up on the LED, the resistors on its other side. Now, what I like to do is actually flux everything and go back on both sides to make it a nice joint. Don't forget to clean your tip if you need to. And sometimes something will come loose and it means that it was never soldered on the other side. Just gotta fix one of these guys. Where's this guy? Is this guy? Okay, there we go. I think we're good now. We've put on all the LEDs in that 330 ohms over here. One more LED 330 ohm we need to put on, which is the programming LED indicator. Okay, so notice very carefully what I'm going to do. There's a K marking right here. Look at K marking on the board. Oh, can't see it. Board's too chunky. Okay. It's right here. K, cathode, flat side. On this side of the board, K was the other way. K cathode, flat side, that line on the LED. So again, I'm going to do a little blob of solder. Couldn't see that. Right? Put this in place. Good. Flip it around. There we go. Yeah, you couldn't see it again, but it's right here. Right, so R21 is actually a 330 ohm resistor, so I'm going to get a 330 ohm for myself. Now it doesn't really matter the orientation. Generally, I put the black side up because 330 is marked on there. So here is R21, or R12 rather. I'm going to put R12 right here. Here we go. Oops. Okay. Okay, we got that in. What else do we want to get in now? Well, I know that C20 is definitely going to be a 0.1 microfarad capacitor. Oops. So, get the reel. They're also non-polarized, so it doesn't matter which direction it goes in. So I'm gonna, probably should have done this beforehand. So some of these components, you probably should, where's the capacitor? Some of these components, I'll have to get a new one. You'll have to make sure you put them in the right order. Kind of follow the order that we're doing, because if you don't, you'll end up having a harder time soldering. Oof. Remember to wear your safety glasses. It's not funny. You can lose an eye. There we go. And now we have that on. Let's do something else that's easy. Let's do the linear regulators. Now be very careful. There's a 3.3, a 1.2, and another 3.3 part on this board. I'm going to do the 3.3s first. Do not put them in the wrong order, because, you know, if that happens, you'll end up blowing up the board. So let's start with this 3.3, and if you look at the part, it's clearly marked 3.3 on it. Make sure it's 3.3. Make sure it's 3.3, okay? So I'm going to solder it into the 3.3 slot. Right. That's all you need. A little crooked, it's fine. Not too much. Don't want to blob up. Blobbing up is not something you want to do. So, next part. Next 3.3 regulator. Well, let's do it this way. Right? Goes there. You could also do it that way. Put it down first. And then kind of apply heat and lock it in. There we go. So what are we going to do next? we're probably going to solder the other leads in. You want nice shiny joints, no blobs. Okay, so we're ready for the 1.2 part, right? The 1.2 part is marked on that spot. And let's grab one. Here's one. So 1.2 part. What I'll do is apply some solder. Oh, oops. Over there. Go ahead and apply it down here. Work it in. Remember, don't put your iron on for too long. Right, so we got U3, U1, and U2, and those are 1.2 and 3.3 regulators. Make sure you don't mess it up. Make sure you don't put it in the wrong order. What else do we want to do? Oh. On this side of the board, we need the USB connector. Note that all of the components over here are not populated. The components over here are also not populated. Right here in this area, no populating. There is only one populating, which is U6. This is going to be the flash chip for the microprocessor, but the FPGA itself. Alright, so this is going to be the flash chip. It's a micron device that goes here. That's the only thing that's going to go in. Here's an access port for JTAG, and here's another access port for JTAG. This is for the Digilent cable for programming. The USB or parallel cable has this output. Let's put in the, what should we put in next? We could put in, we could put in these headers, although I generally save them for last. These are breakaway headers, so count off. In this case, we start off here. Right, and then I'm just going to go ahead try to break it off. Broke away one too many, or didn't break one enough, so I'll cut this. There we go. This is just through hole, so this isn't as bad. Right, so solder tack one in. Right. Okay. We've tacked it in. Seems to look, well, it's a little crooked on the front. So I'll do this. There we go. Looks a little less crooked now. And I'm going to go ahead and solder. Keep soldering down, right, feeding the solder through. You're looking for a Hershey's Kiss shape. It has to be a shiny joint. Don't fill too much. Go on the other side. When you're feeding the solder, make sure you don't put your hands too close. Leave enough room so you don't burn yourself. Okay, so looks like we got a decent joint here. Let's zoom in a little. It's kind of what we're looking for. Okay. What else can we do? Let's do the other side. Oh, broke one off, too many. There we go. So go ahead and solder. And this looks like I have too much stuff on my soldering iron, so I want to clean it off. Helpful if you have something to hold the board with, but I don't because I have to get it under the microscope. Ooh, we don't want that short. Good. Do the other side. Remember, don't put your iron on the board for too long and it'll burn it up. Great. Now, let's see here. I actually use this programming header, so I'm going to put this in. The single row is a little trickier to put in without making it crooked. And again, if you don't like how something looks, put flux on it. Go ahead and touch it up again, make it look pretty if you want. Things like this is a ground, it's attached to the ground, so it's going to be harder to solder. So let's see here, what else do we want? You know, I'll do the rest of the back later. Right now, let's put in the buttons. The buttons, this guy right here, only goes in a certain way. Look at how it's oriented. Look at how it's oriented. Right? Oops. See how the feet are, right? We want to get those feet this way into the hole. Okay. Okay, so I'm back. They kind of had free pizza, so I went and got some. But remember, you are supposed to wash your hands. Wash your hands before you leave the lab, or before you go touch anything else. You have flux and solder on your hands, and you know what? I don't particularly want to eat any of that. I'm going to do some resistors next. Capacitors, sorry. I have a reel of them, so I'm just going to dump some on the board. For the most part, all the capacitors on the resistors on the back are the same. So C24. Let's see. Let's zoom in a little. C24. Let's go right down the line here, and I'm going to clean the tip a little. I'm going to do what I did on the front, and I'm going to do it by row. So I'm going to apply a little bit to get it to stick. So if we look here, C24, C15, C5, C19, and C6, and C13 are all 0.1 microfarad capacitors. They do not matter which orientation you place them in. Not polarized. So I'm just tacking one side on. I'm going to come back later and tacking the other side. These are 0603 parts, so they're tiny. They're probably the tiniest I do. And remember to keep wearing your safety glasses at all times. Okay, we got tacked in on one side. What I'm going to come in and do is just fill in the other side. Remember, less solder is better than more. And don't apply heat for too long either. Okay, so I accidentally put some solder on C25's, both of C25's pad. I'm going to use some braid, some solder wick, and you don't want to hold on to it because it gets hot. And clean off those pads. There we go. They're clean now. I'm going to do what I did before. Go ahead. Do one side only, and start going down again with C25. You want to get them as flat as you can, the capacitors that is. Let's see. And because you're so close, when you apply heat, you have to apply it very quickly because you may be moving other components. And let's see, C22. There we go. I filled in one side. Now I'm going to come back and fill in the other side. Remember, less is more. Don't apply heat for too long. Okay, we completed that side. Let's go to C16, C11, and C9. Oh, and C10. We'll apply it on one side. And I think I need more resistors, so our capacitors. I keep saying resistors. If you do this a lot, you might as well invest in a good soldering iron and a good set of tweezers. I'm currently on the Heiko FX888 soldering station. It's a pretty good station, has a lot of tip selection, good even heat, comes with a stand. I think it's available for $99 at Fry's Electronics or on Amazon. Sometimes it goes on sale for $69, which is even a better deal. Okay, there we go. That side is soldered in. Now we have the other side of C capacitors. Do this one. C17, C21, C7, C18, C12. And I'll get more capacitors. Okay, so let's see, C17. Oh. Sometimes you'll have to clean your tip. There we go. Much better. Pick another capacitor for C21. There we go. C7. C18. C12. And I'm going to go back and touch on the other side to lock them in place. Oh, too much on that one. Doesn't matter though. Okay, R107 and R106. There they are. What I was looking for earlier was R107 and R106 because I need 330 ohm resistors in that spot. So we're going to do the same thing. I believe I put R107 and R106 on the back because I ran out of room on this design on the front for a reason, to put in a reasonable spot. You know what? I don't even care that it's white up. Oh, well, uh-oh. Sometimes if this gets heated by the iron too much, the component, you'll have to just grab a new one. And I just almost broke a pad. There we go. I actually did yank a pad off. A little bit too hot. And then there we go. R106 is in place. So next resistor would be R107. Right? R107 needs to be in place. Can barely see it, but that's okay. Oops. It's not a good connection, but it's good enough. So C27 and C26 and C14. I can also tell that these are 0.1 micros. Why? Because I remember the design. If you do not remember, then you should refer to the bill of materials to build the board. And these are 0.1 microfarad capacitors, 0603s. So let's see, let's go back on the other side, touch it. Remember, if you leave it on too long, you'll start moving other components because the area is small and there's a lot of heat. Now, before I got distracted by the free pizza, I was putting in the buttons, so I still have to put in the buttons. So let's go ahead and put in the buttons. Here goes another one, and here's another button. Look at the way the leads are aligned, right? The leads have to come out this side. And they pop right in on this design because they actually put in the right footprint. Let's see, so we need to solder all these buttons up. Some joints will take longer than others because they're connected to the ground plane. This entire area over here is the ground plane. These on the right hand side may take longer even with this because it's a larger area to heat up. And I'm going to have to clean my iron again. Okay. In this case it's not that bad. And let's see. And this design is based on the Xilinx Spartan 6. I'd actually like to take the time now to thank Xilinx for their donation. So it looks like the front of the board is pretty much done except for the memory, the flash memory at U6 as well as U5, the oscillator. So let's look at U6. Let me see if I can find the U6. Okay, so I found memory. Let's see whether it... Put it in. It's a Micron device. And obviously it comes in an ESD package. So it's going to go right here. I'm going to take this memory, and if you look at the words ST in the corner, the words should read the same direction as the Spartan. So what I'm going to do is turn this around a little, and okay, I'm going to tack it into place. So what I need to do is just tack it in one corner, right? I'll move it into place, making sure you have enough room on both sides to solder. And I'll solder each pin. And I think it's time to tin my tip. Okay, tin the tip. Yeah, that's much better. Oh, so if you just saw there's a blob, I just moved it off to the next pin. Sometimes you can get away with that. Sometimes you'll have to come back with a wick. And remember, don't apply too much pressure when you're soldering. So remember, no populating, no populating, none of this gets populated, none of this gets populated. This is for a separate control circuitry that we don't put in. It's a USB programmability. So we put the chip in, Spartan's in. Let's see if I can find the oscillator. Okay, I found the oscillators. And they're either going to be 50 or 100 megahertz. Okay, so this is the oscillator. We'll flip it around. This is this right side up. It's going to say espresso on it. It's going to have a little dot in the corner. The dot goes towards my pin 1 marking. The pin 1 marking is right there. It's there. You can barely see it. Right? I'm going to turn the board around. Right? And look very carefully at this device. It's 6 pins. We only use 4 of them. So we're going to align it here. And I'm going to pick up some solder. And now we're soldered in place. Right? There we go. Remember to leave both sides, room on both sides, right? Okay, soldered all 4 pins. I think we're good with the front. But what I've realized is the oscillator needs C26 and C27 should be 15 picofarad. We're going to remove these. There we go. And to get a nice clean board, what we want to do is go over Again, clean up. Okay, we clean the pads off. Good, now we can use, what can we use? Let's find the 15 picofarad capacitors. Trying to find another package so I didn't have to open up the new ones, but I guess I have to now. Right, so we got the 15 picos 0603 resistors, capacitors. Now I'm going to do the same thing I did before, which is apply a little solder. Good. Now, I'm going to grab these little guys, solder them into place. Oh, the guy's not flush. Okay, and then the next guy is going to be this. Not enough solder, I'll get some more. And there we go. Grab it on the other side. And sometimes what I like to do is to go back to the previous side, heat it up again, make sure that you got a good connection. So we have, what else do I remember here? Keep in mind that this side over here, all of this stuff should not be soldered, shouldn't be populated over here. C1 is a capacitor which we can populate. And what are we going to populate it with? Well, 47 microfarad capacitors. 47 microfarad. The form factor will be 1210s instead of 0603s. Much bigger, much easier to solder. If I can get it out of the package. There we go. Now I'm going to go ahead and do what I did before. Place a lump of solder. And I'm going to take this capacitor. Oh, this guy's chunky, isn't he? And put him in right here. And I'll heat up the other side. Looks like he's on. So we got this capacitor in. C4, C2, and C3 are next. We got to find the right capacitors for those guys. I wonder what they are and where they are. Okay, I found them. They're 10 microfarad capacitors in an 0805 package. And we need 3 of them for C1, C2, and C3. Sorry, C2, C3, C4. So 0805, so they're a little easier to work with. Repeat what we did before, and I'm going to apply solder to one side. I'm going to pick the part up, place it in, tack it in place, There we go. And I still have enough residual solder to do C2 on the iron. Okay, and then C3. Okay, I'm gonna need a little bit more solder there. Okay. There we go. Got it tacked in place. Now I go back to the other side. And C4. There we go. C4 is done. So I think we've gotten a lot of things done so far. What I feel like doing are these headers next. These are one row. These are breakaway headers, male breakaways. And I'll put these in so we can use power and oops. Breakaway. There we go. That's better. They're not exactly expensive headers, so I wouldn't worry about it. I'm going to tack it in place. On both sides. Then I'm going to start filling in. Since I broke the breakaway header wrong, I need to get more. So, let's see here. Okay, so I got that side done. I still need this side. Put that in, solder, tack one side in. Go to the other side. That guy in. Sometimes it comes loose. There we go. And I'm going to fill in the rest of the holes. Remember, don't apply heat for too long. Don't blob your solder. If you have a lot of solder on your iron, just drag it over. And if you need, apply some flux. You're going for that Hershey's Kiss look. Okay, so we got this header and this header in now. Got your headers in. You got your programming header. This is a header I use. There's also another header for another programmer if you need. Looks like we're almost home free here. Almost home free. What else do we have left? Well, we have the USB micro connector. In this design, it's only used for power unless you populate these circuits. We need to figure out GS4 and GS5, R11, R13, R10. Need to figure these out. So what I'm going to do is go and check the data sheet or the bill of materials and come back later. Okay, so I took a look at the bill of materials. Looks like GS4 says it's a 0 ohm resistor. So I can actually get away with just jumpering them like this. There we go. Short out GS4. Let's look at R11 and R13. Both of them are 10K resistors. So R10 and R11 and R13. $10K 0603s. I'm going to go back to the previous side. Okay, it looks like GS5 is unpopulated. Let's look at R10. What is R10? R10 is a 4.7K ohm resistor, so I'm going to go ahead, populate it with that. Okay, we got our 10 in place. What else do we have? So R2 needs to be soldered. R2 is also a 10K. And R1. R2, R1, R15. There's R2, R1, R15, R16. Oops, too much there. What was R1? R1 was a 2.4. Okay, so R1's 2.4. R15 is 4.7K. So, let's see. And let's see, we have R9 and R16. Those are both 2.4K, so let's pick up a 2.4K again. Oops. The joint's a little blobby. You can get some flux. There we go. Remember, just a little bit, and if you're using a flat tipped iron, keep the flat side parallel with the board. Less is more. So let's see, looks like we got most of it populated here. Let me check with the data sheet again. Let's see, R20, no population. R5, let's check out R5, no pop. R20, nope. R19, nope. Those are for the USB to JTAG programming circuitry, which we don't populate, at least not at this point. What else? GS3 stays blank. This is all programming circuitry, so I think we're good. Oh, you know what we have left? We have the USB header. So let's grab a USB header. This is a micro USB header. We're running out. I need to order more. So, oops. It doesn't sit flush with the board. This is the connector itself. I think there's two pieces that I need to kind of push off because I didn't really quite do the design correctly. The footprint, that is. Gotta bend the weeds a little bit more. Probably fix it in the next revision. So the reason for these two through holes on an otherwise surface mount component is for strain relief. It's so that it doesn't take all the brunt of last year what we did was we used surface mount connectors and it would be really easy to yank off. Looks like we got it. Right. Pads are a little short. Don't put too much because the solder will fill up inside the socket and you won't be able to plug a USB in. And since I didn't do the layout quite right over here, I'm going to flood it with flux a little. Oop, we blobbed it together, which is not good. But before I handle that, before I fix that, I'm going to fill out these two solder holes, which serve as strain relief so that the connector itself doesn't actually break off. Remember, don't fill it too much or else you'll gum up the actual USB micro connector. So back to that area, let's zoom in a little. Oh, look at that, I made a bridge. Well, fucks it up. There we go. You might need to use a braid if you're so inclined to use a braid. Just put it down and suck the solder out that way too, but you use an iron and flux and move it around. Sometimes you get lucky. let's see, there's on the front there's still R17 and R14 that's not populated, and according to this data sheet or this assembly guide, actually it's both, they take 4.7K resistors. So 4.7 over here, and 4.7 over here. You can go ahead and assemble these two resistors in place. Oh, that one's sticking up a little. Okay. So what I'm going to go through is do a final inspection on the board. Make sure I didn't miss any components. Make sure I soldered everything correctly. Make sure there's no shorts. Now that here looks like a short, but it's not. This is just debris. This is just solder. This is just flux right here. In fact, if I brush it off a little, there you go. Yeah, looks like that's soldered fine. Oh, this is why you inspect, because you'll catch something that you didn't catch before. There you go. Removed a short. Would that have been a catastrophe? No. Could have been that that pin wasn't even used, but you don't want shorts. So let's keep going. Keep going. Okay. This looks good. LEDs were connected. Okay, these are soldered. It looks like this board is soldered properly. Now, two methods of cleaning it. You can either stick it in an ultrasonic cleaner, 5 minutes on both sides, or just go ahead, we're going to brush the board clean in this case. This is just 91% isopropyl rubbing alcohol that you can find at the drugstore. And it's just a regular toothbrush. I mean, you could technically get a brush for this, but these are five pack for $1 at Walmart, so yeah. Don't have to be too gentle. And we technically don't even have to clean, but it is a bit of a residue if you don't clean it. So I like to clean it because I like my boards to look pretty. And we want to do a final inspection again just to make sure that we didn't break anything off and we didn't miss any shorts or anything like that. So let's keep going, keep looking here for anything that may be not good. And I don't like how this is dirty, so I'm going to scrub it a little bit more. You can get it much cleaner in ultrasonic cleaner, but it looks like everything's soldered correctly. No shorts. This time I'd like to let the board dry, and we'll come back and try to plug it in. Okay, so what I found out was I put too much solder in, so just had to melt some of it away over here. I also forgot to put R2 in on the back, put that back in. The oscillators were not quite, I didn't quite hit the solder well enough. The other thing I forgot to do, or I didn't do well, was I didn't look at the regulator. U3 was not soldered. One of the pins was floating. In fact, it was this pin that was floating. This is why you want to look really carefully before you power your board on. Now, if you've done everything correctly, you can plug in this USB into here, and this LED should turn on. And we've successfully assembled the owlBoard. Now, the next tutorial will be on how to actually test that all the LEDs and buttons are linked up correctly.